Okay, so now we are in Chapter 8, and what we're going to do is go through the chapter review just to get a refresher or review on Chapter 8 to make sure we completely understand our concepts. So this is Chapter 8, and of course you can find this on page 636. And I'm going to start off by doing problems 1 through 3 and number 5. And in the problems they say determine whether each relation is a function. And it says give the domain and the range of each relation. The relation does not have to be a function in order to give the domain or the range. The domain and range has nothing to do with the fact if it is a function or not. Alright, so the first thing we're going to figure out is it a function? So remember how I told you to remember how to determine if it's a function? Look for repeats in the x's. Okay, I'm allowed to have repeats in my y's, just not in my x's. So each x must correspond to one y. So 3 corresponds to 10, 4 corresponds to 10, and 5 corresponds to 10. Therefore, there's no repeats in my x's. Therefore, this is a function. So this is a function. And then it says, give me the domain and the range. So remember, the domain is always going to be my x values, right? X values. So if I look here, what are my x's? Well, they're 3, 4, and 5. So the domain is 3, 4, 5. And then the range is always going to be the y values. So again, I look up here, what are my y values? 10, 10, and 10. Therefore, the range is just 10. You do not write repeats in here. Okay? Great. So that's problem number 1. Let's move on down to problem number 2. We're going to do the same thing. Is it a function? So look for the x's. Make sure each x corresponds to only one y. So 1 corresponds to 12, 2 corresponds to 100, 3 corresponds to pi, and 4 corresponds to negative 6. No repeats, therefore this is a function. So this is a function as well. And again, let's list out our domain and the range. And again, the domain is the set of all my x values. I have 1, 2, 3, 4. So 1, 2, 3, 4. That's my domain. And then my range is a set of all the y values. 12, 100, pi, negative 6. 12, 100, pi, negative 6. Good. Let's move on down to number 3. We're just doing the same thing, right? So let's see here. 13 corresponds to 14. 15 corresponds to 16. But again, we have 13 corresponding to 17, which is different than what it was corresponding to the first time. Therefore, it's repeating, and this is not a function. So not a function. But I still can give them the domain and the range. And my pen's not working right now. There we go. Alright, so the domain is a set of x's. So I have 13, 15, 13. So I'm just going to write 13, comma, 15. And my range is a set of all my y's. So I have 14, 16, 17. 14, 16, 17. And that's my range. Good. So remember your domain is my x values. X values, and my range is my y values. Okay. Now problem number 5 says find the indicated function values. So remember, g of x is the same as saying f of x, which is the same as saying h of x, j of x, k of x. All it represents is the name. It's the name of my function, g of x. Okay, so in part A it says find g of 0. Well, what's being replaced? The x is being replaced with what? The 0. Therefore, everywhere you see an x over here, you must replace it with a 0. So 3 times 0 squared minus 5 times 0 plus 2 is just 2. Good. How about we do C? And it says find g of negative 4. So first we're going to do the same thing. What's being replaced? The x with what? Negative 4. So let's do that. 3 times negative 4 squared. Make sure you're using parentheses since it's a negative number and you're squaring it or raising it to a power. 5 times negative 4 plus 2. And that should come out to be, hold on, let me do it in my head real quick. 16 times that is 48, 68, 70. So it should come out to be 70. Awesome. And let's try D. It says g of b, g of b. So who's being replaced? The x with what? B. Therefore, everywhere I see an x, I'm going to put a b instead. So it's 3b squared minus 5b plus 2. And of course, you can leave your answer just like this. Oops. Plus 2? Yes, plus 2. Great. So this is all from chapter 8.1. The takeaway is to make sure you understand the domain is the x values, the range is the y values. When it says find the indicated function value, whatever is inside the parentheses, whatever, because remember it's always going to say g of x. If it starts saying g of 0, g of negative 4, and g of b, all it's telling you to do is substitute the x with that value that's inside the parentheses. Alright, so let us move on now to 8.2. And I'm going to need you to look in your book to follow along with me. I'm still on page 636, and I'm looking at numbers 6 through 11, which gives me a whole lot of graphs. And all I want to know is it a function or not based off of the vertical line test? So remember, the vertical line test gets its name from the fact is you draw a vertical line through the graph, and if it hits the graph at more than one place, it is not a function. So here's an example off to the side. Here's just some random thing I'm going to come up with. Here's my graph. I draw a vertical line. Let me get a different color. I draw a vertical line anywhere, and I only hit the graph one place. If I draw a vertical line here, I still only hit the graph, my curve or my graph, yes, in one place. Therefore, this guy would be a function. Okay? Now let's look at number 6. Draw a vertical line in there. Let's see if I can actually draw these. Okay, this is how number 6 looks. Draw a vertical line. And what you want to do is when you pick where you draw your vertical line, try to pick one that actually goes to the graph, You see, I picked 2 up here. You got to be very careful where you pick it at. If I picked it right here, then it will only go to the graph one time. But if I picked it right here, and I drew that correctly, yes, it hits the graph 1, 2, 3 times. So over here you would be thinking, oh, it only hits one time as a function. That's not true. If I draw it in another place, it hits it 3 times, and that's not a function. So not a function. And then number 7. I'm trying my best with these pictures. Oh, that's horrible. But look in your book and you follow along. Again, draw that vertical line. Hits it one place. If I did it here, it'll still only hit it in one place. Therefore, this is a function. Alright, then number 8, I'm going to stop drawing now. So at number 8, those are just points. if I draw a vertical line, I'm only going to hit one of them or none of them, right? So that definitely is a function. Number 8 is a function. Number 9, I will draw out. The spiral. Okay. And again, let's draw that vertical line. Well, let's put it here. How many times do I hit it? 1, 2, 3, 4. Therefore, that is not a function. Number 10. Looks something like this. Let's draw a vertical line. And you see why I keep picking? I keep picking where I know I'm going to hit it more than once. I hit it more than once, therefore this is also not a function. And then number 11. Draw your vertical line. It only hits it in one place, therefore this would be considered a function. And if I also drew it here, I'm still only hitting it in one place, so it's a function. Okay? So vertical line test just means draw a vertical line. If it hits the graph only once, then it's a function, like 11 and 7. If it hits it in more than one place, then it's not a function, like 6, 9, as well as 10. Okay? Let's look at number 12. Number 12 says, express each interval in set builder notation and graph the interval on the number line. So the interval they give you is -2, 3. And the first thing I'm going to do is graph it. So here's my number line. There's -2, and there's 3. And the great thing about having the interval is it basically tells you how to write your parentheses or your brackets. There's a parentheses on -2, and its opening is facing to the right. Oops. So I have one facing to the right on -2. There's a bracket on 3, and it's facing to the left. Great. These guys are going to run into each other, so I just shade in here. Okay? And that's the interval. Now, if I had x, he would live inside this interval, right? Which means he is greater than -2. The parentheses says do not include him, therefore he's just going to be greater. But he would be less than or equal to 3. The bracket says include, that's why I put the equal sign underneath it. So when I'm getting ready to write set builder notation, remember it's just a sentence. It's the set. That's what this curly bracket means, the set. The set containing x such that x is between -2 and +3. Or you can say x is greater than -2 and less than or equal to 3, period. Close the bracket. Alright, so that concludes 8.2. Now what we're going to do is some problems from 8.3, and we really only have, I'm sorry, I'm still in 8.2, aren't I? Yes, I have a couple more problems from 8.2. I went ahead and got some graphs, and I included them in so we can practice finding the domain of a function. I'm sorry, find a domain using the graph. So find the domain using the graph. And remember, I'm sorry, domain and range. And remember, domain represents the x values. So when x goes left or right. So x goes left or right. So you want to find the leftmost point. But this arrow tells me he's going on forever, right? Where is he going? He's going off to -infinity. Which means the far left point is -infinity. And I don't include -infinity, so I use a parentheses, comma. If I was to get on my graph, 1 second. If I was to get on my graph and start traveling, I want to go to the far right point. And where am I going? I'm going to positive infinity. So the domain is from negative infinity to positive infinity. Does that make sense? Find the far left point, and the arrow tells me the far left point is way over here, which means it must be negative infinity. Get on your graph, start traveling it. It's a continuous line. Just keep going all the way to the far right point, and the arrow again tells me to keep going, so I must be going to infinity. So that's your domain. Your range is always going to be your y values, right? And y goes up or down. So you must find the lowest point. And again, let me change my color. The lowest point, again, the arrow tells me to keep going this way. So the lowest point's way down here, which means it still must be negative infinity. And I get on this and I start traveling. Oh, you know what? I can't do the range for this problem. Just for this graph. I just randomly picked out a graph and I see, no, I can't. Yes, I can. Sorry, ignore me. So, go to the lowest place, and that's your negative infinity. Get on the graph, start traveling, and go to the highest place. And what happens? You hit it at 3, and you start turning back around, right? So the lowest place is negative infinity, and the highest is here at 3. Which means it goes up to 3. Now, realize this is a solid line, so I am including the 3. You must use brackets. Let me say that again. Let me actually erase and do it again. Okay, let's try that again. The range is always going to be your y value, so you want to find the lowest place, and the arrow tells me to go on forever, which means I'm going down to negative infinity. Okay, so once I'm at the lowest place, what I want to do is get on this guy and start traveling. And I'm traveling along, right? And I want to go to the highest place because I want to go up. I hit the 3 and it starts to turn back around. Therefore, the highest place is at 3. And since it's a solid line, I am including the 3. So the range goes from negative infinity to positive 3. Here's another graph. Let's do the domain again. Domain's left and right, so you must find the leftmost point, and it's this guy at 3, and you want to get on your graph and start traveling, right? You want to go to the right. And where do I stop at? 5. So the domain is negative 3, 5. Now, if it's a solid circle or a solid dot, solid point, you include the number. So I'm going to use bracket. And if it's open circle, that's right, solid circle, closed circle. I'm trying to think of my language here. If it's a closed circle, you include the point. If it's open, you do not, and you use parentheses. Okay, so let me say that again. Closed circle, use brackets. Open, use parentheses. So that's my domain. Now let's do the same thing. Let's find the range. Okay? Fine, let me get a different color. Find the lowest point on this graph. It's right here. Okay? Now I can go traveling to the left, right? And go up. Or I can go to the right. It all depends on which one will take me to the highest place. These guys land on the same place in the y, right? So how about I go this way? I go to the lowest place and I start traveling. What am I going to hit? I'm going to hit right here. What is y on the x-axis? It's 0. The lowest place was at negative 5 and it went up to 0. So negative 5, 0. Again, this is solid, so I'm including that negative 5, so use brackets. And this is an open circle, so do not include the 0, use parentheses. How about we go the other way? So here again is the lowest point, right? Now I'm going to travel to the left, if I can. And again, I get to the highest place, and I stop. And I'm on the x-axis. On the x-axis, y is still 0. So I still have this right here. But look at something. It's a closed circle versus an open circle. This is a special problem because I just randomly picked it out of the book. And since it's a special case, we are going to, without confusing you, because you'll never have a problem like this in the midterm or final. Remember, I just randomly selected this one. They actually wanted you to do something different to it. We're going to say include the 0. Include the 0 because I'm including it here. If you have the choice between including and not including, if they're going to give you both, you're always going to include. So include the 0. Got it? 0 is included. If you tell me it's not included, then this circle right here will have to be open. Since it's closed, you got to include the 0. Therefore, use bracket. All right. Now we're going to do some problems from 8.3. We're going to look at number 21 and number 23. Number 21. It says f of x is equal to 7x minus 3. F of x is equal to 7x minus 3, and it says find the domain. Well, remember, you need to be looking for a denominator. If I knew how to spell it. Denominator, as well as a square root. If you do not see it, then your domain is simply all real numbers, so it's negative infinity to infinity. All real numbers. Number 23. It gives me f of x is equal to x plus 3x divided by x minus 5. And again, we're going to look for our domain. We're going to look for our domain, which means we should be looking for a denominator and a square root. Well, I see a denominator. It's x minus 5, which means you must take x minus 5 and set it not equal to 0. X minus 5 not equal to 0, and you must solve. So add 5 on both sides. And you have x does not equal 5. So look at the number line out here. Let's graph this. Here's 5, right? X cannot be 5, therefore I must have a break at 5. I have to write a parentheses opening to the left as well as to the right. Because remember, parentheses means do not include. And I have a break, which means do not include 5, but it could be everything else. So you would shade all of this down here. And you would shade all of this up here. So when you're ready to give me the interval, you always give me the leftmost point. What's the far left over here? What is this going to? Negative infinity. So you start by saying negative infinity, comma, you get on this and you start traveling. You're going to hit the brake. It's like you're on the train track and there's a brake in the track. You have to stop. Where are you stopping at? 5, and it's a parentheses. And then you write the U, and then where are you at again? You're again at the 5 with the parentheses opening to the right, and then you're going to travel some more. And where are you going off to? Positive infinity. So the domain is all of this. Okay, this is the domain. It says x can be everything else, but he will not be 5. Okay, this was a long video because I did all of chapter 8 in one. Let me know if you have any questions.